It feels like Monday, but it's actually a Tuesday. You've had a nice 4.2 days off of math because we didn't have math on Thursday, so you guys, our brains are all kind of rotten. But we have 9 questions here, warm up from everything you've learned so far this year. If you're doing this at home and you're practicing right now, press pause, fast forward to the question that you have difficulty with, and see if you did correctly. Our first question is a rational number question involving division of a negative fraction by a whole number. Ways to do it, there's multiple ways to do it, but the easiest way to do it is to convert your mixed fraction to improper, change to multiplication, and use the reciprocal of the second fraction. Since the second number is 4, its reciprocal will be a quarter. Once you do that, you can check for cross reduction if you're intelligent, but if you're not, don't worry about it. Multiply your numerators and multiply your denominators, you get this. Reduce by dividing both by 2, and reduce by dividing by 2 again, and you get your final answer of negative 2/5 for a solution. In your second question, we're dealing with order of operations with rational numbers in decimal form. When doing that, the first thing you should always start with is your multiplication. $3.50 doubled would be $7. So $3.50 multiplied by 4 would be 14, or negative 14. So when I do that without a calculator, that's what I get. And when I add 50 cents to negative $14, I get negative $14.50, or negative 14.5 as a solution. Next question is Pythagoras. Of course, you could start with your a squared plus b squared equals c squared, which is always a good idea to start with the formula. Since your a's and your b's of your formula are always the legs of the right triangle, those two numbers will be your a and your b. So 2.1 squared plus 3.8 squared will equal x squared. Or 2.1 squared, I think I know this one, that's 4.41, isn't it? It is 4.41. 4.41 plus 3.8 squared, I don't know off the top of my head. 14.44, a lot of 4's in here, equals x squared. 18.85 equals x squared. And in order to solve for x but not x squared, what would I have to do to both sides? Gavin, what would I do to both sides here? That's right, I'd square root both sides. Perfect, thank you. The square root of x squared is x, and the square root of 18.85, right there, is approximately 4.3, is approximately 4.3. So therefore, the length of x is approximately 4.3. Next question is algebra, solving for x. What value of x is given in this equation? We have fractions, and there are two ways to solve it. I like adding 3/5 to this one. I don't hate it. In fact, I would probably do it myself here because it probably saves me some time if I did that. So getting rid of the constant of negative 3/5 will result in 17/20. Multiply both sides by 2. I'll get x equals 34/20, or 1 and 14/20, or 1 and 7/10 as a solution. So if you were one of those people that decided, you know what, I don't think I need to multiply both sides by 20, you got that. But since most of you multiplied both sides by 20, let's see what happens. What's half of x multiplied by 20? Andrew, that's right, it's 10x. Good stuff. What's negative 3/5 multiplied by 20? Negative 12. And what's a quarter multiplied by 20? It's 5. Once you have that, add 12 to both sides. Divide both sides by 10. And you get the same answer that we got over on the other side. Doesn't matter. Either way is fine. Next question gives you a chart, asks you to convert to decimals and to percentages, or fractions, decimals, and percents. So we have 3/8, which is kind of an easy one because 1/8 is 1.25. So I know from experience that it's that because every eighth is equal to 0.125. So therefore, three of them would be three 0.125s, which is that. But if you didn't know that, you can always change a fraction to a decimal by dividing the numerator by the denominator to get that answer. And that number is 375 thousandths. So if I think about it as a fraction like this, as an equivalent fraction of this, I would see that what percentage is it? It's 37.5%. Or, since we now know about fractions, you could technically write it like this if you wanted to. In the second question, it gives us the decimal of 0.02, which we would read as 2 thousandths. And since percentages are out of 100, by the way, that's your fraction, 2 thousandths. Or in lowest term, 1/500ths. But since percentages are out of 100, if I make an equivalent fraction, I divide this by 10 and divide this by 10, I get 0.2 out of 100, or 0.2%, or if you're really intelligent, 1/5 of a percent. And finally, your last one, it gives you the percentage of 150%, which is 150 over 100, which is equal to 1.5. So as a fraction, 150%. Andrew, do me a favor. And the last one is a decimal. If you don't know that 1.5 is 1.5, you're in the wrong class. But 1.5 is 1.5, so as a decimal, 1.5 is 150%, which makes sense because 1 is equal to 100%. And that is equal to 50%. So if we think of it logically, 1.5 does make sense that it's 150%. Our next question, now we're getting into some great stuff. We have a rectangle with algebraic notations for side, both length and width. Perimeter, we know, has a formula of 2 lengths and 2 widths. And area is simply length times width. So we think of our two formulas for perimeter of rectangles and area of rectangles. That's what we would use. We would have 2 2x minus 1s, and we have 2 3x squareds. Using distributive property, we get 4x minus 2 plus 6x squared, which technically is our answer. But we always know it's best form to reorder them in descending degree of terms. So therefore, your perimeter would be, in descending degree of terms, that trinomial. When we look at the area, length times width, I'm going to make 3x squared, my monomial, my first term, and my second term, my width, I'll make my binomial, only because I'm accustomed to seeing distributive property being monomial times polynomial. Using distributive property, I get 6x cubed minus 3x squared, and therefore that, since none of them in the binomial are like terms, that is as simplified as I can get for the area. Our next question from our exponent unit says -3 squared, which of course means -3 times -3, which is a positive 9, plus 2 to the exponent of 5, which is 2 times 2 times 2 times 2 times 2, which I think is 2, 4, 8, 16, 32. Which means -3 squared plus 2 to the exponent of 5 is, in standard form, 41. Next one is the square root of 16/100ths. Now, without a calculator, what we learn to do, 16/100ths, is think of it as a fraction. Those are the same question. And then ask ourselves, what fraction multiplied by itself is 16/100ths? Numerator is 4, denominator is 10. So therefore, the answer is 4/10, or more importantly, since it's decimal form, 4/10. And you could, of course, grab the calculator and say, what's the square root of 16/100ths? It would still tell you 4/10. And our last question is the surface area of a rectangular prism with algebraic measurements. So our formula is 2LW plus 2LW plus 2LW because there are 6 faces. If we think of the front as being the red one here, it's 2 5x times 3x. Those are the length and width of that rectangle there. If I think of the green as being the left and the right, it's 2 5x times 4x. And if I think of the blue as being the top and the bottom, there are 2 of them, top and bottom, it is 3x by 4x. So once I write that down, I know that there are 6 faces. This would be 15x squared, and there's 2 of them. So the sum of those 2 faces will be 30x squared for area. I should have done that in red, but whatever. Plus, this is going to be 20x squared, and there's 2 of them, which means those 2 are going to become 40x squared. And there are 2 12x squareds, which is 24x squared. Oh, it is. It needs 2 plus signs, so we're okay there. Now that we have those written algebraically, they are like terms. So this trinomial can be simplified down into 94x squared equals the surface area of that rectangular prism.